First, let me explain the concept and characteristics of the programming language. The programming language is a systematic representation of what we want the computer to do in its language. A natural language, the means by which people communicate, is a high-level language that freely expresses people's thoughts and feelings. But computers are not very intelligent machines, so the language that computers can actually understand is a machine language combined with numbers 0 and 1. It is very difficult to combine these machine words and use them to develop the complex programs. So it is a programming language that allows users to program in a language similar to those used in everyday life. And every programming language has its own translator that converts your program's source codes into machine language, for example, a compiler, an interpreter, etc., so that the computer understands these languages. In addition, each programming language has different usages, so you need to use appropriate programming languages in each application area to achieve the desired productivity and quality. As shown in Table 2, Fortran and Algol 60 are mainly used in general science and technology. COBOL is widely used for business use, and Lisp and Prolog languages are used for artificial intelligence. PLS, Bliss, Algol, and C, C++ are used for system programming. For special purposes, GPSS is used for simulation. Very few languages are perfect in many programming languages, so it is common to find the programming language best suited to your program according to the following programming language evaluation criteria. Click on each to see more details. Readability is the degree to which a programming language can be intuitively understood in understanding its structure. This is evaluated based on simplicity, orthogonality, and syntax concern. Looking at specific criteria, the syntax within the program itself is not complicated and the basic skeleton is not too large. And you should be able to separately understand the basic functions and characteristics of the programming language. In other words, when the functions are not mingled and then they are combined, their interaction should be free. It is also important that user-defined types, keywords, and reserved words are well organized, and the syntax is the same format and meaning. Ease to write refers to how easily a programming language can be used to write a program. The language chosen will depend on the areas of programming discussed before and are evaluated on the basis of simplicity, orthogonality, abstraction, and expressiveness. Looking at specific criteria, the syntax within the group itself is not complicated, and the basic skeleton is not too large. And the basic functions and characteristics of the programming language must be understood separately. In other words, when the functions are not mingled and thus they are combined, the interaction must be free. You also need to be able to define and use complex structures or operations without the detail information. And the problem-solving strategy should be able to represent the program structure naturally. Reliability refers that the program perform its specification without errors under all conditions. Language features that affect program reliability include type checking, exception handling, and aliasing. Let's look at the compilation language and the interpreter language. There is a translator that allows the computer to understand and run programs written in the programming language. That is, a software developer has a compiler and an interpreter that translate a program into a machine language. Each of them allows a software developer to translate the program into machine language and run it. However, because the compiler and interpreter run the programs in different ways, it is necessary to understand the differences between the two translators. First, a compiler language means replacing a language into another language with equivalent semantics. The compiler translates the high-level language into machine language, which is a low-level language, to create an object module, link, load, and execute it. The compiler languages include Fortran, Pascal, and C, C++. The following figure illustrates the compilation process. The compiler is used to translate existing source code into executable code and run on a computer. The advantage of the compiler language is that it allows you to save the translated object code. After it has been compiled, you can re-execute the program as it is. So in case of which a program is reused, it can be run quickly again and even speed up the execution time. Conversely, the disadvantage of the compiler language is that it takes time for converting to machine code. A single line of source code is sometimes translated into a few hundred lines of machine language, which can cause a memory waste. Next, the interpreter language executes the source program at the same time, changing the source language into a low-level language directly without intermediate process. In the translation process, a high-level language is only translated up to intermediate codes and executed by a software interpreter, which is calling a subroutine, equivalent to the function of each intermediate code, not by a machine language program. Typically, the interpreter languages include Lisp and Prolog. The following figure illustrates the interpretation process. Unlike the compiler, the interpreter directly executes the translation at the same time with translation, and thus there is no an executable file during the intermediate process. The advantage of the interpreter language is that it is useful for interactive programs because it is executed when needed, instead of waiting for a complete machine translation for the first run. It keeps the source language format until the second program runs, so you do not need a lot of memory. On the contrary, the disadvantage of the interpreter language is that it takes a long time to decode and process the source program each time it is run again. We will look at the process of software development and the evolution of major programming languages. In 1960s, it was the time that computers were used for large-scale calculations and military purposes. That's why the usage of programming was limited. The requirements were simple. The machine language was used and there was no development method. In 1970s, it was a time of high-level languages. As the use of computers has expanded to the commercial sector and customer requirements have arisen, systematic approach has become necessary. 1968 software crisis had emerged and the waterfall methodology turned up. In 1980s, it was when personal PCs became popular. At this point, C appeared and the fourth-generation language tools started to appear. In the meantime, customer needs have become more complex and software development methodologies have emerged from a lifecycle perspective. It is considered the software as one of big business, and grow the software and hardware customized for the customer. Apple's Lisa and Macintosh have been very successful with a user-friendly UI. In 1990s, it focused on project efficiency and productivity. Software was recognized as a high value-added market rather than hardware, and there was a lot of investment from companies. So big projects with a lot of risks are on the rise, and the development methodology considers risk management, customer requirements compliance, and productivity. As a result, the object-oriented language and the iteration and integration process were born and popular. RUP was born based on the iteration and integration process, and CBD, a component-based methodology that inherited RUP, became prevalent. In 2000s, it was a time that customers and services were transforming and applications were becoming more and more web-based. In order to anticipate customer needs and address the challenges of building them in a short time frame, the development has become to reorganize the productivity focus and focus on easier to develop. This will lead to develop various automation tools. And now, considering the convenience of developers as well as the needs of customers, software development is becoming increasingly personalized from the enterprisization and grouping. With the breakthrough development of the tools, multiple development languages work the same under one platform, and a developer can do from the planning to the testing tasks him or herself. In other words, the user will soon become a provider, and the software industry will increasingly become a platform strategy for building the ecosystems of finding, developing, and distributing software that meets customer needs. On the screen, the programming languages list the year in which they were born. Especially, the language marked in red has been successful in the industry, and it is a language that is still used by software developers and programmers. I will continue to explain the most commonly used languages. Fortran is the first advanced programming language. It is developed by J. Backus and others in IBM. It is widely used in science and engineering. Algol 60 is a language established by the Algol Committee, an international standards body. Based on the language theory, it is the first language described by BNF syntax format and is often used for numerical calculations. COBOL is a language for commercial data processing. It can process large amounts of data and perform simple calculations, and it is very easy to understand the program because the language syntax is similar to the English syntax. BASIC is the first language of time sharing. It was easy to learn, and because it is possible to implement the program with very little memory, it gained much popularity among programmers in the early microcomputer era. Pascal is an educational programming language. The syntax structure of the programming language is diverse and easy to understand. Next is C++. First, C is a programmer-oriented language born out of designing an operating system at Bell Labs. Because the program design is systematic, portable, robust, and flexible, it is the most fundamental language in developing various programs, games, and software development. As C++ is a language that combines C language with object-oriented programming, it is based on features that existing C has. Lisp is the first functional programming language. It widely used in research and implementation of list processing and artificial intelligence areas. ADA is a very powerful general-purpose language. This is a language for military embedded systems that focuses on parallel processing, exception handling, and program maintenance. Java is the most widely used language in the world today. It is the language for developing the core business of web pages, especially the financial sector. The main reason is that it has compatibility, portability, memory handling, and it is especially the most perfect language for communication between people and computers. Recently, as the usage of smartphone devices has increased, you can easily access Android using Google Java source codes. It is based on Linux, and various software and hardware can be ported. Android boasts Java for the highest market share and recognition in the mobile market. I will explain the program development process. Program development is generally done in 5 steps as shown in a screen. This develops high-quality programs that meet the needs and requirements of customers and users. Step 1 is the problem definition and analysis. This is the phase of defining and documenting the problems, needs, and requirements of customers and users. Second, it is the design phase. In this step, you define the solution by going through problem-solving strategies and its reviews. In particular, this step is divided into 2 phases, high-level design and detailed design. The high-level design breaks down complex problems into multiple, simple components through technical trade-off analysis, definition of implementation risk, overall architecture definition, and top-down approach. The purpose of detailed design is to design a logical processing sequence using similar codes and flowcharts to minimize the coding errors with more clear and structured descriptions. Third, during the program coding stage, the solution strategy is expressed in a computer language and input to the computer. Fourth, it is the program test. In this step, you will perform test checking and programming debugging. Test checking refers to remove the presence of an error and check the correctness of the program's logical structure before running the program. Programming debugging refers to the elimination of errors that a program contains. Fifth, it is the program documentation and maintenance in the last step of the program. In this step, documentation and maintenance are performed. Documentation refers to documenting how to use the program. Maintenance refers to activities that keep programs always good condition, error-free, and up-to-date. Let's look at C language among main development languages. C is a language devised by Dennis Ritchie, who worked at AT&T's Bell Labs for the Unix operating system in the 1970s. Most computer languages have a C language as its motif. Currently, there are no operating systems that do not have C language. iPhone operating system, iOS, and Android are also rooted in C language. Let's summarize some characteristics of C language. First, C language is efficient. When written in C, the program is relatively light, so execution speed is fast and memory is effectively used. In addition, C language is a high-level language that is human-centered language that is used while programming, and it is a language that simultaneously has the characteristics of a low-level language that is machine-centered language that only computers can understand. Second, C language is concise, so you can easily implement functions with paragraphs instead of making a difficult effort. Third, C language has excellent portability. In other words, it's already used in many kinds of hardware, so easily ported in any hardware. Fourth, C is a procedure language. That is, when the program is executed, it proceeds in the specified order. Also, it may be harder to learn than object-oriented language. C is the most widely used programming language in the world by the 1980s, loved by the most people. However, C language has also come to the limit. As a result, C++ language has emerged to manage highly complex programs. C++ includes most of the features of C, making it suitable for system programming. Also, it's suitable for object-oriented programming with features such as class, operator redundancy, virtual functions, and so on. And as there are many parts that match C, there is a big advantage in the relevance that C programmers can easily adopt C++. For reference, let's look at some of the languages that support object-oriented programming. The concept of object-oriented programming can be found in Simula 67, which introduced the concept of classes for the first time. Since then, we have secured that concept in Smalltalk, which has the first graphical interactive programming environment. C++ and ADA 95 also support object-oriented programming. Developing the software using object-oriented programming techniques makes it possible to reuse software, and it is easy to expand and maintain them. Therefore, it is good for developing large programs and also the readability of programs. Let's summarize some of the features of C++ language. First, the defined classes are well used in encapsulated form, but it has the feature that actual internal operating structure are hidden, so the user does not need to know how the class works and only knows how to use it. Second, C++ has reusability through inheritance. Here, the inheritance refers to the process of creating a class by making the common characteristics of multiple classes, then scale it and creating new class. The base class is called the parent high-level superclass. Inheritance increases program reuse and improves software productivity. Third, C++ has polymorphism that has multiple forms in a single name. For example, Hong Gil Dong is a hard worker at work, but he is also a hard-working student at school after work. It means to have different roles or meanings depending on the situation in the one interface called Hong Gil Dong. Since 1991, Sun Microsystems has begun to develop Java, a simple bug-free programming language that controls home appliances, driven by James Gosling. James Gosling predicts that consumer electronics will be linked to one immense network, and that built-in programs that take on the functions of the product will be used as a single part. And whenever an embedded program is upgraded, it downloads a new program from the server through the network to improve its function. Initially, it started with C++ language, and the Java language was developed improving many problems in C++. But the consumer electronics companies were not interested. However, in 1995, the spread of the Internet called www became widespread and applied to the Internet by Hot Java, and then a powerful output form called applet became popular. The applet was also shunned because it is executed by completing the download in the browser and was slow to run. However, Java language has been recognized, the advantages of which it has a small, simple structure that has been efficiently changed and implemented and complemented the various functions that cause errors in existing languages. This is why Java is now positioned the most popular programming language used in apps and mobile. Let's look at the characteristics of the Java language. First, Java language is simple. Java from the C++ language is a language that is syntactically similar to the C++ language and simplifies the complexity of C++. One of the biggest differences between the Java and C++ languages is garbage collection. Java always performs automatic garbage collection. In C++, the garbage collection requires to take advantage of additional libraries by performing explicit memory management. Second, Java language is a complete object-oriented language that applies the object concepts. And third, Java language is an independent platform. The platform is a hardware or software-based environment in which programs can run, and as Java programs are run by the Java virtual machine, it is platform independent. As well understood, IDE indicates an Integrated Development Environment, an acronym for Integrated Development Environment. The IDE is an integrated software that basically includes an editor, a compiler-interpreter, and a debugger in one framework. The history of IDE can be explained by the confrontation between Borland and Microsoft. Borland released Turbo C and Turbo Assemble, followed by Turbo C++, so that they dominated the IDE market in the late 80s and early 90s. Microsoft, a company that promoted traditional development tools such as GW Basic, Macro Assembler, and Microsoft C, released IDE products such as Quick Basic and Quick C, but it was not enough to break down Borland. But as Windows 3.0 emerged, things quickly reversed. While Borland was struggling between DOS and Windows, Microsoft released Visual Basic and Visual C++, the hits of the past. Borland had tried to counterattack with Delphi too late, but it was not enough to deal with Microsoft. Any development tool was treated as an IDE. The development tools that are not IDEs are beginning to be called SDK. As Microsoft was slowing down because of slipping into narcissism, Java became a mainstream language, and thus IDEs for Java come to a sudden appearance. However, first-generation Java IDEs such as Borland's JBuilder, Symantec's Visual Cafe, and Microsoft's Visual J++ had followed the existing IDE by merging the editor, compiler, debugger, and GUI designer, and thus could not be dissolved the typical characteristics of dynamic language like Java in the tool. IBM's Visual Age for Java and Sun's NetBeans have been dropped by the premature concepts. Eclipse appeared as a comet as Java developers became accustomed to solving everything using Edit Plus and Ant scripts. Eclipse is a Java rewrite of the Visual Age series developed with Smalltalk a long time ago. Eclipse has started to monopolize almost all IDEs beyond Java, as its name implies. Platform SDK vendors, who were forced to create IDEs for market needs, and those who did not make IDEs for their own language were much easier to rely on Eclipse. Eclipse is now poised to thrive in the heyday of Eclipse, but it is predicted that there will be a light and wide range of features of IDEs that follow and penetrate the drawback of increasingly feature-rich Eclipse. Recently, Xcode, which is a collection of OS X development tools developed by Apple, is getting attention. Xcode's main program is an integrated development environment of the same name, and it includes an interface builder for creating the graphical interfaces and the documentation for Apple developers. Xcode includes a modified version of the open-source GCC and includes a variety of programming models for Cocoa, Carbon, and Java. It also supports C, C++, Fortran, Objective-C, Objective-C++, Java, AppleScript, Python, and Ruby. Let's take a closer look at Eclipse, an integrated development environment tool. Eclipse is an open-source project written in Java. It is a representative Java development program for the IDE that can be used on various platforms. The start was aimed at a programming integrated development environment supporting various languages, including Java. Now, however, it adopted OSGI and has evolved into a general-purpose application software platform boasting powerful features. The latest release of Eclipse is 4.7, and there are various versions for C and C++ developers, Java developers, and web developers. The foundation of Eclipse is the Rich Client Platform, RCP, and let's take a look at its components. First, there is a core platform on which Eclipse runs the plugin. There is OSGI, a standard bundling framework. There is a SWT, which is a portable GUI widget toolkit. There is a JFace that simplifies the configuring task of advanced components using SWT. And there is an Eclipse workbench, which includes views, editors, perspectives, and wizards. Eclipse uses a plugin to provide all of its functionality, including RCP. This plugin mechanism can be a lightweight software component framework. Using these plugin frameworks, it's possible to extend Eclipse to other programming languages other than Java, for example, C or Python. You can also use a typography language like LaTeX in Eclipse. You can also run network applications such as Telnet. Database management is also possible. And you can also extend the development environment itself with a plugin architecture. For example, you can extend the enhanced configuration management capabilities with built-in CVS support. The Eclipse SDK includes the Eclipse Java development tools. It has a built-in Java compiler, provides an entire model of Java source files, and JDT allows you to perform advanced refactoring techniques and code analysis based on the Java language.